Okay, here we go. Here are the notes for this new material that we're starting now. It's called the Law of Sines. Law of Sines. Now there's also law of cosines, and we'll see that after. But there's a couple of things here for the law of sines that we're gonna have to recall. So this first video is gonna be quick. It's just kind of looking back at some prior knowledge and seeing some of the information and the material that we're gonna use here. The first one is this. Again, up until now, we've worked with right triangles, which means you can do Pythagorean theorem, right, to find missing sides, right? Up until now, we've done right triangles. And for right triangles, you can use Pythagorean theorem. And you can use the trig identities, right? The trig functions to find missing sides and also to find missing angles. You can use sine, right, which was so. And then you can use cosine, which is ka. And you can use tangent, which is toa, right? We've been using that. Well, now you can't use these anymore. You're not going to be able to use them because remember these can only be used for what? Right triangles. And what we're going to get into now is using these new formulas, again, and this one's called law of sines. Again, this can be applied to right triangles only. Now, the law of sines, and also later when we see law of cosines, you can also use them for right triangles, but this is for all triangles. And specifically, they're not gonna have a what? Not gonna have a 90-degree angle. They're not gonna be right triangles. You can't use this. For these triangles that we're gonna use now, you cannot use the a squared plus b squared is c squared. You can use SOHCAHTOA, you can't. But you will be able to use the law of sines, right, to find missing sides and to find missing angles. Okay, so this is where we start applying the law of sines. Is for triangles that are not right triangles. Okay. Another thing that we want to review here before, what's true about right triangles and what's true about all triangles? And the answer is the interior angle sum. Interior angle sum. What is interior angle? Well, the angles on the inside. Interior angle sum is still 180 degrees. That's true for all triangles, right? It's just like saying what's true for all triangles? Well, they all have three sides. We know that for a right triangle, again, even though we're not going to work with right triangles, right? We're working with the non-right triangles. We know if this one's like 20, then we know this is 70, right? We know that these three have to add up to 180, right? 20 plus 70 plus, obviously this one's 90. It's equal to 180. Well, it's also true for non-right triangles. Now you're going to see triangles that's not a 90-degree angle, right? So they're going to give you two of them. For the law of sines, they're going to give you two of them. So definitely you're going to know the third one, right? If this is like 42 degrees and this one looks like 28 8 degrees. What's this one? Well, again, that's prior knowledge. From what I know from geometry, I know that whether it's a right triangle or whether it's not a right triangle, I know that 42 plus 28 plus my unknown angle is equal to 180. And then you can figure that out, right? So just quickly, just reminding you about that. Let's see, what's 42 plus 28? That's 70. These add up to 70, so I believe that's going to have to be 110, right? 110 plus 70, 180. Okay. So you understand that now we're going to be using the law of sines. Again, you don't know what this is yet, but just understand you can't use these properties. You can't use the Pythagorean theorem and you can't use SOHCAHTOA because that's only for right triangles. Okay, so what is true about triangles? Well, we know they have 3 sides. We know that the interior angle sum is 180. What's another thing to remember about triangles? Okay, well, just quick notation here. And again, we're going to be using all of this. They're going to label these triangles, right? They're going to use different vertices here. So let's say this is, right, these vertices are these corners here, right? There's 3. Obviously, the vertices are capital letters, capital A, capital B, capital C. So they're going to use the capital letters for the corners, for the outs, for these angles, right? This is angle A, this is angle C, this is angle B. But then we got sides, right? We got 3 angles and we got 3 sides. While the sides are the lowercase. So the uppercase letters are the angles at the corner, the vertices. And if this is angle A, this is side A. The one opposite of it, right? Across, opposite. If this is angle B, you look across and it's going to be what? Well, this one over here. That's side B. And you have to make sure you label these right? And if that's capital C, well, you look, if not, you want to just follow the 2 lines and make segment AB, right? Follow the 2 segments for that angle and it makes this is side C. All right. So let's try another one real quick. If I have one that looks like so, again, remember they're not going to be, and what if this is D, E, F? Capital letters would be the angles, right? The corners. And the lowercase are going to be the sides, the side measures. We got angles happening, we got side measures happening. So this is D. That means this is, or just look at across, right? This is side D, lowercase. Angle E, side E. Angle F, side F. Okay. One other thing here, right? So we're kind of reviewing, we're kind of just looking at things that we've seen applied before in the past. Okay, we understand we can't use this. We can't use Pythagorean theorem. We can't use SOHCAHTOA. You're going to be finding missing side measures and missing angle measures. But you can't use this. You're going to use the law of sines, and we'll get to that in the next video. Another thing that you're going to really use a lot from before, again, it's easy when you did it in Algebra 1, Algebra 2, but it's going to be a little bit more here, proportions. Some of you are like, oh, I've heard that before. I forgot what it is. Okay, proportions. Proportions is when you have something like this. An example. X over 6 equals 4 over 8. A proportion is when you have a ratio or a fraction equal to another ratio or a fraction. How did we learn to solve this? Anybody remember how to solve this? How do you solve a proportion? When you have something that's like a fraction equal to another fraction. How do you solve it? Well, to solve, you cross multiply. Cross does not mean across. Not multiply, across. Across means you'd multiply like this and you'd multiply like this. No. Well, now that I said it, I'm sure you remember. X over 6 is equal to 4 over 8. You would cross multiply is like multiply like this diagonally across. Cross like an X cross. And I always start with the part with the missing, with the variable. So that would be what? 8 times X equals, and then the 4, and then you multiply these parts. It's 4 times 6 times 4. Well, I think we got it right. That's going to be 8x equals 24. You're going to get x equals 3. Okay, so we're going to be using all this, accessing this prior knowledge, applying it, and I'm going to introduce in the next video how you're using this with trig and pre-calc. All right, go to the next video, print out that worksheet first, and you don't have to draw all those triangles and things. All right, go to the next video.